Why the universe can't end. Humans naturally think in beginnings and endings. We understand something has a start or an end because we compare it to something outside itself, something that keeps going while that thing changes or stops. But when it comes to the universe as a whole, there's nothing outside to compare it to. No before or after beyond it. So the idea of a real beginning or a true end just doesn't make sense. The universe can't really start or die, at least not like we usually think about it. The longing for an ending. We love stories with a beginning, middle, and end. This way of thinking is deeply rooted in our culture, in how we process life, and even in science. When we talk about the universe, the biggest thing we can imagine, we often picture it having some dramatic finale. Modern cosmology suggests three major endings. First, the Big Freeze. The universe cools down, keeps expanding forever, and eventually nothing much happens anymore. Second, the Big Rip. Everything gets torn apart by accelerating expansion, even space and time. Third, the Big Crunch. Expansion reverses, everything collapses, maybe even leading to a new beginning. These scenarios are impressive and backed by solid math. But here's the thing. They all assume the universe is moving towards some final goal, a closing chapter in its story. The problem with these endings. Do these models really explain what an end means? Not really. The Big Freeze isn't a disaster. It's more like the universe hitting a thermodynamic pause. It still exists, just without much change. The Big Rip is an extreme prediction, but no one knows what comes after the universe gets ripped apart. Maybe it's a transition. The Big Crunch sounds cyclical, like an endless loop, but right now it's mostly speculation based on limited data. So all three are forecasts of possible states, not true endings. Energy remains, the end does not. Physics agrees on one thing. Energy can't be created or destroyed. It just changes form. That means a real end of the universe, where everything simply disappears, is physically impossible. Even in a Big Freeze, energy is still there, just in a form that seems dead to us. In the Big Rip, matter might break down, but the energy stays. And in a Big Crunch, energy would get squeezed together but not vanish. Energy doesn't die, it just transforms. So the universe remains, even if it feels strange or final to us. Another way to see it. The open universe. But what if the universe doesn't actually need an ending? What if it has no goal, no final destination? What if it's always changing, transforming in ways we can't predict, maybe even changing its own rules as it goes? Think of the universe not as a novel with a final chapter, but as an open field of processes. Not a story with an ending, but a flowing stream with no set destination. This isn't just a new theory of how the universe ends. It's a fresh way to think about ending itself. It invites us to see the universe not as a movie with credits, but as an ongoing, open dynamic. Why we need this view. It's an important expansion of how science sees things. It reminds us that all models are just approximations. Our knowledge always has limits. It stops us from mixing up scientific ideas with metaphysical truths. It helps us stay humble about what's unpredictable and open to what we don't yet understand. And it's grounded in physics. Energy conservation means a real end is off the table. From trying to understand to letting be. Maybe the universe isn't meant to be fully understood. Maybe its core is open change, not fixed order. Maybe no end isn't science failing, but science taking its biggest step forward, learning to think about openness. Not just explaining, but also accepting what can't be closed. If the universe isn't a story with an ending, then our role changes too. We're not just watchers of a cosmic drama, we're part of an eternal becoming. Maybe the deepest meaning isn't in figuring out the end, but in marveling at what never ends.